Hey guys, the objectives for this video are to discuss the real behavior of columns and to discuss other forms of buckling. So some of the factors that affect the behavior of real columns is the lack of straightness. So if you've got an initially bowed or crooked column, that's going to therefore be able to withstand less of a load before buckling. If you've got eccentric loading, so that means that the load isn't applied directly to the middle of your section, it's applied a little bit off to the side, and that adds additional moments to your column. Variability in your cross section, so if the cross section is not constant, it may want to buckle in a certain location where the cross section is possibly thinner. And then also residual stresses, so when you form a section, you might not have the same yield stress at each location, and therefore you might get yielding at a certain location before another. And then just the yielding of the column itself. So once you reach yielding, your column has failed before it has buckled. Euler versus real column behavior. So under the Euler equation that was derived a few videos ago, the buckling load was determined as pi squared E I over the effective length squared. So that gives a line that looks a little bit like this. But in reality, our real column is actually going to experience behavior and axial capacity with respect to the effective length of the radius of gyration, more like this, which is slightly lower than that of the real column, and it sort of tapers